The thinking is that the Tharsis region bulged out when a giant dome of magma pushed up from the planet's core. The volcanoes grew large because Mars lacks the constant shifting of crustal plates that on Earth leads to chains of smaller volcanoes, like the Hawaiian Islands. Just to the east is the great Valles Marineris, named for the Mariner 9 mission that found this vast gash in the Martian landscape. It's about 4,000 kilometers long and up to 200 kilometers wide. On Earth, Valles Marineris would stretch from Los Angeles all the way to the Atlantic coast. If you went to Valles Marineris, you'd see dust devils sweeping along the plains above it, and dust blowing up the canyon walls. Here's a realistic rendering of data captured by spacecraft. Giant landslides have caused the walls to slump off and pile onto the valley floor. Feeding into the valley, a maze of side channels. Scientists think these and other tributary features were formed when underground water flowed into the main basin and the land above collapsed. Wider parts of the canyon are regarded as possible landing sites for a manned mission. They offer flat surfaces and possible access to liquid water that may remain below the surface. The theory is that Valles Marineris formed when the planet began to cool. Its sides were pulled apart as the Tharsis Plateau just to the west began to rise up. That chain of events is now being linked to a much larger planetary event. What one scientist called the defining moment in Mars history. Travel north down the slopes of Mars' great volcanoes. The elevation drops as we move across what appears to be an immense ocean, colored here in blue. With this so-called Borealis Basin in the north and the high elevations of the south, Mars is a lopsided planet. In fact, there is a difference of about 30 kilometers in the thickness of the crust in these two regions. Here's the reason. Early on, when the solar system was young, Mars was hit by at least 15 large asteroids. Scientists have linked these events to a time around 3.9 billion years ago, known as the Late Heavy Bombardment, when rock samples from the Apollo landings show that our own moon was seriously pummeled. One theory holds that these impacts heated the outer subsurface layer of the planet, Mars' mantle. That prevented molten rock in its core from rising up and caused the crust to thicken. This had the effect of shutting off Mars' magnetic field, exposing the planet to damaging solar winds, and over time, turning it into a wasteland. There are other theories that explain the disappearance of Mars' magnetic field and its atmosphere. What's certain is that at some point early in its history, the red planet grew increasingly desolate. The Martian landscape we see today is replete with coded signals from these early times. Ancient riverbeds and lake bottoms, floodplains, and volcanic cones, as well as the battering it received from impacts. But is Mars a dead world? Maybe, maybe not. An infrared telescope on Hawaii's Mauna Kea volcano was trained on Mars over several years. Astronomers used a spectrometer to split the light into its individual wavelengths to identify chemical fingerprints in the atmosphere. They found the signature of methane gas in amounts that change from place to place. Because methane should disappear quickly in Mars' atmosphere, there must be some source that constantly replenishes it. That source could amount to nothing more than the chemical reactions in Mars' crust. Or it could be biological in nature. Perhaps microbes alive and well in heated pools underground. So far, neither the satellites flying over Mars nor the robots on the ground have turned up anything close to clear proof of life. It may take the searching eyes, flexible minds, and nimble fingers of human explorers to find that buried treasure, if it exists. In the meantime, we are finding that even if Mars is dead, it's certainly not dull. Mars has nowhere near the dynamism of Earth. With its oceans, atmosphere, volcanism, and shifting continents. But it does do some fascinating things. If you take an atmosphere, however tenuous, add heat from the sun, you get the renowned dust devils of Mars. With no trees to hold the soil down, landslides are common. The Mars Reconnaissance Orbiter has returned images showing that Mars is actively remaking its surface. Not in canals built by the Martian engineers of Percival Lowell's imagination, but in sand dunes shaped by the wind, and in landscapes molded by a gradually changing climate. Some scientists have even turned up hints of low-level plate tectonics. Whether or not we ever find life forms on Mars, we can still marvel at the beauty of our neighboring planet. Its surface subtly sculpted over eons of time. On a world that never was.